2024. Will you please join me for a minute of silence? Thank you very much. Will you please stand as you're able for the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Alright, good morning guys. I'm about to lose my voice here, so you're going to have to bear with me a bit. We need to talk about one quick new thing today, and then we can spend the rest of time practicing and getting better at related rates that we talked about last class. So 35, we're going to talk about how to find the derivative of an exponential function now. Again, this only takes about 3 minutes to talk about the whole thing here, so very quick. But I will put, I think your next test has one or two of these, and except for last year, it's generally one of the more missed questions. Not because it's tough, but I think because you guys don't worry about it because you don't think that it's tough, and then students don't review it like they should. So keep that in mind so that doesn't happen to you. Okay, so here's the formula. If you want to take the derivative of an exponential function, something to the x power, this is how you take its derivative. But honestly, you pretty much know that already. You may not realize it, but we've done this one a million times. The derivative of e to the x is e to the x. Technically, it's e to the x times the natural log of e, but since the natural log of e is just 1, we just always say e to the x. But if you realize there's really a natural log of e there, now you already know how to do exponential functions. 3 to the x, his derivative would be 3 to the x times natural log of 3. 7 to the x would be 7 to the x times natural log of 7. Of course, natural log of 3 and natural log of 7 are not 1, so you would have to keep those as part of its derivative. So again, if you just really think about e to the x is e to the x times the natural log of the base, you can just extend that to any exponential function. And of course, the only way to make that harder is to think about the chain rule. So if it's something to some power, a number to some power, you're going to get that number to that power times the natural log of the base times chain rule, the derivative of this inside stuff, the stuff that you're plugging into the function. So 8 to the x squared is going to have an 8 to the x squared times the natural log of 8, just like we did above. But since this inside does not have a derivative of 1, we need to multiply by his derivative. So times 2x is chain rule, and we'd probably make the answer look like this. Something like that. So exponential function, just like e to the x gives you e to the x, 5 to the 2x gives you 5 to the 2x, but since the base is not e, you need to multiply by the natural log of the base and consider chain rule. This one would be times 2. Yeah.
Or would it not be 16x to the x squared since x is in the exponent?
Oh, yeah, you're right. I'm sorry. Let me redo this. this should be, I wrote it as too sloppy. It should be 8 to the x squared times the natural log of the base times the chain rule step. So after that, we can't do anything. Thank you for catching that. Okay, so for number 6, this is the last one. What's the first part of our derivative for number 6?
X cubed plus 5x minus 1.
Okay, so all that. And then somebody else tell me, what else do we need? Times the natural log of 10. And like all derivatives, whether it's product rule, power rule, quotient rule, something we memorize, this falls under one we memorize, times the derivative of what's being plugged into 10 to the x or 10 to the u. This is the chain rule step, so times 3x squared plus 5. All of that makes up the derivative. It's not difficult. And again, I think in the past, students don't think it's difficult, don't worry about it, but then they don't review it, and then it ends up being one of the most missed questions on the third test. I gave last year's class a warning of that, and they did much better. So hopefully you guys will take heed to that as well. Okay, is there anything you want to clarify about this topic, derivative exponential functions? Okay, well, last time we started talking about related rates for the first time. So what I'd like to do is help you out with a couple of your questions that you should have had from homework. So I asked that you had tried all the rest of those. So if there was a few that you found to be harder than the rest, I want to help you with them. The rest of the class, we're going to focus on related rates now. So partly me helping you with last class assignment, and a little bit of you practicing and helping you with today's assignment. Today's is 36. This one's called basic related rates. While you get out 34 and see what questions you have. 36 has the answers to the first 6 on the bottom of the page. The second, third, and fourth page are all multiple choice with the answers to those at the end. Of course, when I take this up for points, you will have to have work shown. If you just pick answer E for number 11, because I tell you it's answer E, I'm not giving you homework points for just circling it. You got to do the work too. So I think all of these multiple choice questions are past AP questions, so it gives you an idea of how difficult they expect you to work these. The last thing I'll say about 36 for now is on the third page, question number 6 is significantly harder. There's a couple things about it that makes it harder. So if I was you, I'd put a star by it and probably save it for the last. Even though I've worked that question like, I don't know, probably 30 times at this point, I still always struggle a little bit with that one. Just, you'll see what I mean when you do it.
Question?
Number 6 on the third page. So I still want you to try it. I don't want you to do it early and then spend a lot of time on it. Maybe just try it at the end when you've tried all the rest that are more reasonable. That one's not a good difficulty level. Okay, so I guess if you have, it's probably not many people, if any people, but if you don't have any questions from that circuit, number 34, then you can go ahead and start on 36 and get a head start there. But for everybody else, let me help out with a question or two, and then we can pause for a moment. Try to let my voice recoup for a minute. Okay, so from your classwork / homework last class, which ones did you, were you not able to figure out?
I'd look at the key for 11 and 12.
Okay, it's on the website. You'll need to pull it up on your Chromebook. Yeah.
Can I go to 12 because I have the derivative, but I don't know how I get the actual x value.
Sure, but you need to tell me which one's 12.
The second to last one.
On the back page?
Yes.
This one?
Yes.
I think this is the last one,
Yep.
if I remember right. Oh, okay. You said second to last. I'm sorry, my brain's foggy today. All right, so this is an interesting question, and I wish we had more time to talk about this specific real-world example, because any of you that go into business, this is why they expect you to know some calculus for business these days. If you want to get a business degree at the University of Arkansas, they expect you to take at least Cal 1. So they come out and tell us that profit is revenue subtract cost. Here's the cost function, here's the revenue function. We are supposed to construct the profit function. Construct the profit function. So profit will be equal to, if it's revenue minus cost. Revenue is all the money you take in. Cost is the money that you have to spend to get the stuff. So we could do R, which is 50x, and then take away C. So that's the profit function. Revenue, all the money coming in, subtract cost, all the money going out. Whatever is left over is your profit. And of course, we should probably distribute this. What am I doing? Distribute negative, positive, negative. Okay, then you can think about derivatives, because they're giving me lots of rates in here. Now the rest of this question is not a great real world question, but if you're running a business someday, you are trying to maximize cost, or minimize cost, maximize profit, stuff like that, which is another thing we do this semester. Okay, so you had mentioned that you did have the derivative, Leah?
Yes.
Okay, so to take the derivative of 50x, most of the time that's just 50, but with related rates, we're taking the derivative with respect to time. X is not the same thing as t, so you have to create an x prime. Just like when you took the derivative of y with implicit, it created a y prime, because we were taking the derivative with respect to x, and y and x are not the same. X and t are not the same. Do the same thing here, power rule, but realize you took the derivative of x with respect to t. Power rule, but realize you took the derivative with respect to t, so x prime. This one I'm going to rewrite as x to the negative 1. So I could do power rule and then times x prime, because I'm taking the derivative of x with respect to t. Every single time I took the derivative of x, I created an x prime. Okay, and then this just gets a little bit messy here. I was working this one out yesterday, but they tell us this value is 4.544. This is 50 times x prime, which is 0.05. I don't know what x is. X prime is still 0.05. I don't know what x is. X prime is still 0.05. And x prime is still 0.05. So we are supposed to figure out, bless you, the x value, not the x prime, they told us x prime, but the x value that makes this true, to figure out when that derivative, when the rate of change of the profit is 4.544. Okay, so is that how far you got? Okay, so shortly, like within a few classes, we'll talk about, I have a circuit on calculator stuff, just making sure you know how to use your calculator to solve things like this. And let me freeze my screen for a second, but I'll show you a couple different ways to go about this. I'm going to, usually I would use a graph, maybe graph the left side and graph the right side and look for intersection points. That's perfectly valid. hold on, I'll put this back up in just a second. Oh, well, you can see it now, actually. So, another way to get your calculator to solve some complex equations like that, no one's expecting you to solve that by hand, but with a calculator you should be able to do it. So, I'll introduce you to, if you go to math and go to the bottom, there's a thing called numeric solver. In numeric solver, you can put one side of an equation in for E1, and then the other side of the equation in for E2. So that's what I was going to do and come back and show you. So this was 50 times x prime minus 3x squared times x prime plus 8x times x prime plus 50x to the negative 2 times x prime. Okay, I think I have that typed in correctly. But basically, if you go to equation solver, you give it one side of your equation, give it the other side of the equation. You can press down to go to this next screen, and then this is where your answer is going to be. But this is not the answer. This is the answer from last time I used this. It must have been 10. If you hit alpha enter, notice how it says solve in green right here. So when you do that, alpha enter should update this number to the solution. So the solution is 1.185. So again, let me say that real quick again, just so you know this is an option. Normally I would solve something like that with graphing, but I think the equation solver was a little easier. So math, bottom option called numeric solver or equation solver. Put in one side here, put in the other side there, go down, down, alpha, enter, and then we'll update this x equals to the solution. Okay, was there anything else about that one? That was 1.185. And that was the last one that looped back to the start. Hold on. Okay, nobody needs to ask anything else about 12. Okay, what you got, Noah?
8, the one right below it.
Okay. All right, if you did need help with that one, make sure you did not need help with 8 before you move on. Okay, salt for winter road maintenance is poured so that it forms a conical pile. That's fancy math speak for a cone. Such that the radius is twice the height. Radius is 2 times h. Find the rate at which the pile is growing in feet cubed per hours. So the fact that this is feet cubed tells me it's talking about volume. Only volume has cubic units, and it's got a time component, so that's v prime. When the radius is changing, so r prime is 0.5 feet per hour, and when r measures 2.5 feet. Okay, so when we looked at this last week, remember I said every question just is quite a bit different. One question could be about a cone, the next question could be about a circle, the next question could be about a sphere. You have to step away from every question looking the same. What's consistent is you need to try to extract all the information they're giving you. I would suggest underlining it and listing it out. At some point you've got to come up with a formula that matches this shape and these variables. So since this is a cone, what is the volume of a cone formula?
1/3 pi r squared.
Alright, it's only got one base, so 1/3 times the area of the base, pi r squared, times the height. Now, so that's the formula you should be working from. Now here's what's going to happen. And this is a good thing for you guys to learn from, because it should also have happened to you in question 11. When you take the derivative of this is just a number, so I'll pull it out front. V becomes V prime. For this stuff, you can do product rule. You can take the derivative of r squared with h left alone, and then the derivative of h with r squared left alone. Just make sure that when you take the derivative of r, you create a r prime. When you take the derivative of h, you create an h prime, because we're taking the derivative with respect not to r or h, but to t. The problem with this is they don't ever tell you, nor do they give you, enough information to solve for how the height changes. So it's not that this is wrong, it's just a path that creates information that I need to know that I don't know. I don't know this, I also don't know height, and you kind of hit a wall. So the trick to this is, well, it's the thing that I didn't use. If r is 2 times h, I can say that h is r divided by 2 for this question. So for this question, instead of saying h, I could put r over 2. So for this question, I can say the volume is 1/3 pi r cubed over 2. So I'll just make that a 1/6. And now it only has r stuff, and so when I take the derivative, it's only going to have r's and r prime stuff, which is good because that's what I have. So you had to leverage this, change everything in terms of r, so that when you took the derivative, it only provided, only created stuff that you knew the answer to. So then you plug in your r, plug in your r prime, throw all that in your calculator, round to 3 decimal places, and it should come out to be 4.909. This is pretty common for cone questions. For cones, there's usually a relationship between the radius and the height that allows you to eliminate one of the variables. Likewise, if they had told me stuff about h and h prime, I could have substituted the r squared stuff for h stuff, and then I would have the variables that I needed. So this that's highlighted only applies to this question because they told me. That's the only reason I could assume that there. Okay, did you get what you needed there? Yeah. Okay, I'll take a couple more questions from this, but give me just a minute, please. I got to make it through the whole day without blowing my voice out. So if you would, even if you still got a couple more questions there, go ahead and start on 36 for a minute. Again, the first 6 questions have the answers at the bottom, so make sure that you're checking those as you go along. And then after that, I think those are all AP questions, so they will vary quite a bit in difficulty.
Number 35, the sheet. Would there be something that could help you fill it out on that?
The class recording that will be posted on the website later.
It's not going to come to the SAP website.
It'll be in the top left. It won't be posted till after class. Don't worry about it right now. Okay, somebody who has not asked a question yet from last class's circuit, was there a different one besides 8 and 12?
You do the last one on the second page.
Last one on page 2. This one?
Yeah.
All right, I have this down as question 10. All right, volume of a cube is 125 cubic centimeters and is changing. So V prime is changing at 8 centimeters cubed per second. How fast is the surface area changing? So I don't want to know what the surface area equals. I want to know how the surface area is changing. So the derivative of surface area in centimeters squared per second. Area always has squared units. Volume always have cubic units. So all that seems fine right now. Alright, so based on this, based on the shape, I think that they want me to use the volume formula. So I'm not 100% sure, but I got to start with something. So volume of a cubed, this has two bases, so you could do area of the base, side times the height, side, which gives you side cubed, or you could memorize it. But when I take the derivative of this, I get V prime. Over here, you do power rule. But again, I can't emphasize this enough because this is the make or break. If you're taking the derivative of S with respect to time, you have to create an S prime. The only variable you would not create a prime for would be t, if you're taking the derivative with respect to t. Okay, I can start plugging this stuff in. I know B prime is 8. I don't know S for S squared, and I don't know S prime. So I kind of hit a wall here. That's okay, because they also gave me a hint here. I'm really trying to find the derivative of surface area. So surface area is when you add up the area of all the sides. So a cube is going to have 6 squares. So six square areas. And so I guess if I can figure this out, I could plug that in up here. So the thing I haven't used yet is this. They told me what the volume is. So if the volume is 125 and the volume is also S cubed, that must mean S is 5. 5 times 5 times 5 is 125. So actually, I guess I can plug that in here. This would be 5 squared. This would be 6 times. Yeah, but I don't really care about the surface area. I care about the rate of the surface area. So if I take the derivative of this side with respect to time, and then take the derivative of this side with respect to time, here's where my answer is going to come from. So I need to know what S is. I just figured that out here. It's 5. Sorry, my 5's and my S's look the same. And I need to know what S prime is. So even though this seemed like this was a dead end and that it was not useful, it is useful, because at some point you have to solve for S prime as well. So now that we know S is 5, S prime is 8 divided by 3 and 25. So 8/75. Plug that in here and throw all of that in our calculator, and I got 6.4. So that one's kind of weird because you have to use the volume formula and its derivative to find some information, and you've got to use the surface area formula and its derivative to find the answer they actually want you to find. Okay, did that get you past where you were stuck? Okay, anybody else going to ask about 10, need something else out of it? Okay, let me offer one more. Anybody who has not asked one yet today from the circuit last class? Yeah. Number 11. Yes, 11 is a great one to ask, and I'm surprised y'all didn't ask this one yet. This is number 11. All right, we've got a conical drinking cup, so that's a cone, but of course you want the opening at the top, not the bottom. Has a height of 6 inches, a radius of 2 inches at the top, put that in my notes just in case. How fast is the water level in the cup rising? So to me that sounds like the rate of change of the height if we're pouring in water at 1 cubic inch per second. So that would be the change in volume. I know it's volume because it's cubic inches. That's a little bit of a hint. And the water is 2 inches deep. Okay, so this is kind of like number 8 that you guys asked about, where this is a cone. You are expected to know the volume of a cone formula. You have to memorize that if you don't know it. But since it's got one base, it's 1/3 times the area of the base, which is a circle, times the height. And you can start doing the derivative here, which would have to be product rule. And then just like question 8, you hit kind of a roadblock because they give you a ton of information. They don't give you all of this stuff. I know what V prime is. I know what R is at the top too. That's not really the R all the time. R prime, I have no idea about. H I know. H prime is what I'm trying to find. And R squared, well, I only know R at the top. So you start to realize, man, there's a lot of stuff in here that I don't have ready to plug in. Also notice there's some conflicting information here, the way I wrote it. It's that I have the height is 6 inches and I have the height is 2 inches. The 6 inches is the total for the cup. 2 inches is the instant that we're interested in finding how this is changing. So a lot of times with cones, again, just like question 8, we can eliminate some of these variables here. We can either get rid of the R stuff or the H stuff. The fact that I want to find H prime and I know H means I should try to eliminate the R. So if you break this down, you've really got a right triangle here. And so if we use this information about the whole thing, he has a height of 6 when his radius is 2. That allows us to make a relationship here. The height is 3 times what R is. And you need to realize that this is proportional, so it's always the same. Whether the water's always to the top or as you go down, height is always 3 times whatever r is. That's what this is telling us. And because of that, I can say r is h over 3. And because of that, instead of saying r squared, I can say h over 3 squared. So this would be 1/27th pi, and we'd have h cubed. And this is still before the derivative. But this is significantly better, realizing this relationship between r and h. Again, you really only need to do this for cone questions. Because now when I take the derivative, bless you, I'm going to need to know h. Not a problem, I got it. I need to know v prime. Not a problem, got it. And that's going to leave behind h prime, which is what we've been trying to find the whole time. But if you don't eliminate a variable, if you don't eliminate the r, your derivative after product rule is going to be asking for information you don't have and you don't have a way of getting. So this is the only way to move forward. So that's a 1. This is a 2. And so in your calculator, 9 divided by pi divided by 4 gave me my answer of 0.716. That's a very good question to ask, because this did not come up, and that's not necessarily intuitive to most people, but all right, so in my opinion, that probably made that question the hardest of all of these. Does anybody want to ask anything else about it while it's still up there? Okay. Let me pause here again for just a second, and then if you have any more, I will take another question or two. Okay, sorry about that. Okay, is there more that I can help with from last class's 34? Whether you asked the question yet or not. Yeah.
Can you go over 7, please?
7.
Another question on page 2.
This one? Okay. Alright, Charlie Brown flies a kite at a constant height. I guess. Alright, and it's 100 feet up. The wind's carrying it away from him horizontally at a rate of 2 feet per second. How fast must he release the string from the spool in feet per second? So this is the string. So when he runs out of string, how many feet per second is that going to be going when the kite is 300 feet away from him? Now, one thing that would worry me about this is sometimes you guys will put the 300 down here. That's the horizontal distance, but the distance from him to the kite is this. It's the straight distance. So 300 is supposed to be up there. So he's letting off all 300 feet of string, and then we're trying to figure out how fast that string is flying out there as it releases from the spool. Alright, so I look at this, see a right triangle, so it's probably going to be Pythagorean theorem. Take the derivative with respect to time. Make sure you get your a prime, b prime, and c prime. Feel free to divide everything by 2 to simplify it a bit. C has to be the hypotenuse, so I know this is 300 and what I'm searching for. The other 2 sides don't matter so much. One side needs to be called A, the other side needs to be called B. So A, I know, is 100 feet. A prime is how that's changing. Well, it's saying that it's staying at a constant height of 100 feet, so it's not changing. So A prime is 0. Plus B, which I don't know the length of, times B prime, so the rate that B is changing, which is 2 feet per second. And so I'm left with 0 goes to 0, so I'm left with this. And I realize if I'm trying to solve for C prime, I still have to find B. That's the extra information that I need. So if I focus in on this right triangle, here's what I've been calling B. This side's 100, and this side's 300. So with Pythagorean theorem, B is going to be the square root of 300 squared minus 100 squared which is the square root of 80,000. And then our answer comes from dividing both sides by 300. So 2 times the square root of 80,000 divided by 300 gave me 1.886. Is that okay? All right. Anybody else want to jump on this one? Anything about this question? This is the type I told you is the most common. Right triangle, Pythagorean theorem. The most common type of related rate. Okay. Sounds like we've exhausted those questions. I'm not going to ask you to turn that in today just because I can ask for it next time. But you should have that finished. So if you have not moved on to 36, there's no reason not to by now. So as I've been saying with 36, in case you're just now looking at it, the first 6 questions have the answers right here. So please make sure it's correct before you assume it's correct and move on. Honestly, I don't remember too well. I think all of these are pretty much the same level of difficulty. Maybe number 6 was a little bit harder. But then after that, okay, and I'm right, I didn't make up this worksheet, but all of these multiple choice questions come from past AP exams. So I like to show you these so that you guys can see what the true difficulty is you need to be able to do once you really think you've understood those. So question 6, I'd probably save for last. Unless you just really feel like you're great at these. You'll see why I say 6 is a little bit harder. It's not the math that makes it harder, it's just the way they presented the question. But all of these multiple choice questions have the answers at the end. So again, to get homework points or class points or participation points, whatever you want to call them, you need to make sure you have the work that goes along with it. I'm not interested in just the answers.
Wait, when you said number, okay, so it wasn't the AP questions that 6 was hard, that we should say for the end? It was the front page?
No, it's the AP question that I would say for the end.
So it's 6 for both.
Yeah. It's not that it's impossible, it's just, again, you'll understand when you try it. Okay, so obviously I want to help out a little bit here too. I know related rates take a little bit longer before you feel comfortable with them, but again, the only parts that I can help you with is provide lots of practice and emphasize that even though every question is different, you know, there's a geometry formula, you know, you're taking the derivative of it with respect to time, you know, you're plugging in all the information. On the easy questions, you solve for what you need. On the harder questions, sometimes you've got to dig deeper and try to find an extra variable or two. So let me give you a minute of work time, and then I'll see how I can help, or offer to help at least.
For 6B, I got exactly half of that. I don't know why. Let's see.
So right here, is that the work for that part?
Mm-hmm.
What happened to, like, this is your A prime.
Yeah.
5 times 3.
Yeah.
What happened to your B prime?
Well, my B is like the base is not changing.
Oh, it's not, okay.
Yeah.
I'm not sure. Let me work it out on the board.
Okay.
Because then I can't see your mistake. Okay, I'm going to look at question 6 here in just a second. Just in case you feel like you want to watch question 6, I'll wait just about 10 seconds to let you find a stopping place first. All right, question 6. Two sides of a square are increasing. I'm going to do both parts, so you're welcome to tune out until the second part. But two sides of a square are increasing at a rate of 3 centimeters per second. So that's how his sides are changing. Oops, but that's a length, so just regular centimeters. When the sides are 5 centimeters, at what rate is the area increasing? Okay, so this is a two-parter. This is part A. So square, talking about area. Area of a square is A equals S squared. Derivative of left and right side with respect to time. Make sure you understand why this is A prime and why there's an S prime there. And the answer to the first part is just going to come by taking 2 times S, which they gave to us, times S prime, which they gave to us, which ends up being 30. And if you keep up with the units, centimeters times centimeters gives you centimeters squared, and then it's per second. So that confirms with that. So first part of that was pretty easy. All right, second part, at what rate are the diagonals increasing? So it's a square. This diagonal and this diagonal are the same size, so they would be increasing at the same rate. So I guess we're still using this same information here. The length is 5 and the rate is 3 for both of those. But for the second question, if you're interested in how this diagonal is changing, you're probably looking at just this right triangle. I don't really care that it's a square anymore. So down here, Pythagorean theorem. Derivative with respect to time. Simplify everything by dividing by 2. And then if we start plugging stuff in here, all right, yeah, this is where I guess your mistake was. I think B prime's not 0. B prime should be 3.
But wouldn't the parallel lines be the only ones that are able to? Because if the two ones that like make the right triangle were increasing,
Mm-hmm.
then all four of them would have to increase in
That-
order for it to.
That's
be
correct.
square.
But even if all 4 are increasing, why would that change the diagonal? Like as this one changes and this one changes, the diagonal is going to change, right? So the other sides are changing too, okay, but the diagonal is still changing. So notice when you start plugging this in, this length is 5 and its rate is 3, so that's 15. This guy is 5, his rate is 3, that's 15. C, I can find with Pythagorean theorem. 5, 5. This one is, you could do Pythagorean theorem, but I can cheat. I know how to do that. It's 5 square roots of 2. And so the answer should come from 30 divided by 5 divided by square root of 2. Which is 6 over the square root of 2. Oh, I don't need a decimal. 6 square root of 2 is what they got. Yeah, so your assumption that this side was not changing as well. Because it's a square, if one side's changing at 3 centimeters per second, all sides have to be changing at 3 centimeters per second. Otherwise, it's not going to be a square anymore.
Can you solve for decimal and then just check to see if it's the same as
The other diagonal?
No, like, can you just, if you didn't solve using the square roots, if you got a decimal, and then
Okay, the only problem with the decimal, so like if you put this in your calculator, you get 4.243. The only issue would be that on free response, you can do a decimal as long as you do 3 decimal places, always 3 decimal places, even if the directions don't say it. But as multiple choice, it might be written like this. So I guess if you have this, that must mean you have a calculator to round it. So you would just need to like put in choice A in your calculator, look at its decimal. Put in choice B in this calculator, look at its decimal. Maybe this is choice C, you put it in the calculator, and when you see they have the same decimal, then you know that that was the one you'd want to pick. So
Could we do it the same way on this packet?
yeah, that's fine, I guess. I don't know.
I mean, we're not given multiple choices for these first 6 questions, but if our answer is the same as the...
Yeah, that's fine.
Okay.
Worrying about fractions versus decimals on this assignment is not that important. Okay, is there something else on the front page only right now? Any other 1 through 6 that you've tried? I'm sorry?
3.
Number 3. Gravel is falling in a conical pile. So, as we saw in the circuit, cone problems can often have one unique little twist to them, but I can see that it's already addressing that here in the directions. It's falling at a rate of 100 cubic feet per minute, so that would be how the volume is changing. Okay, I know it's a rate because it says per minute. I know it's volume because it's feet cubed. Cubic units always go with volume, just like area units are always squared, if you didn't get it out of the context of the question. Find the rate that the height is changing. So we're trying to find h prime when the height is 10 feet. And then assume the coarseness of the gravel is such that r is equal to h. Okay, so since we're talking about a cone, this is probably the hardest formula they expect you to memorize. They don't expect you to memorize volume of a sphere, but volume of a cone gets thrown out a lot. Again, it's got one base, so it's 1/3 times the area of the base times the height, so that you don't really have to memorize that. You can take the derivative of this right here. Is that what you did? Okay, but make sure that if you do that, you're doing product rule. This is r squared times h. So you can do the derivative of r squared with h left alone plus the derivative of h with r squared left alone. You have something like that? Alright, the problem with this is I don't know, and I'm never going to be able to figure out how big r is, nor am I going to be able to figure out what r prime is. And if I don't know those, I'm never going to figure out how big h prime is. So again, just like on our circuit, this is very common for cone questions only. Because of this, since r is equal to h, I could either change this h to an r, or I could change these r squares into h squares, whichever one that I prefer. Now, if I change them to r's, when I take the derivative of this, I'm going to have r's and r primes, which is the problem I had with my last derivative. If I change them to h's, now when we do the derivative, we only have v prime, which we know, pi is just a number, we have h, which we know, and we have h prime, which we're trying to solve for. So it is unsolvable without making that substitution, changing this into this because of that. And again, that doesn't happen on every cone question, but it is likely to happen on cone questions.
Where does the third go?
This third,
Yeah.
I did power rule.
Oh, wait, so you times...
This was not derivative, this was derivative.
Okay, I got it.
Okay, is that enough? Okay, one more from the front page. Yep. 5. You guys have the question in front of you. You don't need to see it. A small balloon is released at a point 150 feet away from an observer on ground level. So observer, 150 feet. A balloon is let up in the air. If the balloon goes straight up at 8 feet per second, how fast is the distance from the observer to the balloon increasing? So that would be this. Straight line represents how far you are away from something when the balloon is 50 feet high. Okay, so now that I've got a picture, I think I've labeled all the information where it's supposed to go. Probably a Pythagorean theorem problem. So after the derivative, after dividing everything by 2, we get to there. Still okay with this? Okay. We have no option but to call this C. So I don't know the length of C, and I certainly don't know C prime, because that's the whole point of the question. But I'll call this A and this B. I do know A is 150, and A prime, how is this length changing? It's not, so that's a 0. B is 50, B prime is 8, so we get 850s, which should be what, 400? Okay, now obviously when I read this question and when I made my picture, I had no idea that I was going to have to figure out the length of C. That's okay. You guys need to understand, just do what you can, and then when you get closer and closer to the answer, it's gonna be obvious what other information you need. Alright, so now if I focus on my right triangle, when this is 150 and this is 50, I could do Pythagorean theorem here. And this becomes the square root of 25,000. So it looks like our answer should be 400 divided by Oh, okay, so I know what they did. Are you still okay with what I did? So I would just divide this and say my answer is this. Or if you gave me a calculator, I would throw this in the calculator and get a decimal. As we talked about earlier, if you have a calculator to make this a decimal, you could, if it was multiple choice, you could plug in all of the choices in your calculator, compare decimals, and pick out the one that has the same answer as them. But if you're curious how they came up with that answer, they did is they broke down the square root of 25,000. That's a big number. Looks like the square root of 25,000 is the same thing as a 5, a 5, a 2, a 5, a 2, a 5, a 2, and a 5. So square roots, we need things in pairs. So a 5, a 2, and a 5. So bring out a 5, bring out a 5, and bring out a 2. That would be 50, and leave behind a 10. So instead of calling this the square root of 25,000, you could call it 50 square root of 10. And then if you reduce this, 400 over 50 would be 8. And then 8 over the square root of 10, you could rationalize. You could multiply the top and the bottom by the square root of 10. That would give you 8 square root of 10 over 10. And then when you reduce that fraction, you get 4 square roots of 10 over 5. That's where they made it look like that. So, I don't know. I guess without a calculator, you would have to go through all of that to try to figure out that that answer was equivalent to that. But quite a bit going on there. Okay, so just for a change of pace, how about the next pages that are multiple choice? Have y'all tried any of those besides question 6? I don't want to get into question 6 today.
Can you do number 3?
Number 3? Sure. Okay, a person 2 meters tall walks directly away from a street light. Just going to cover this up for more space. That is 8 meters above the ground. So 8 meters, here's my street light. A person's walking away from it and they are 2 meters tall. If the person is walking at a constant rate and the person's shadow is being lengthened at a rate of 4/9 meters per second. So here's the street lamp. So it's hitting the top of his head and it's creating a shadow. If the person's shadow is lengthening at a rate of 4/9 meters per second, so we know its rate, at what rate in meters per second is the person walking? So how many meters per second is he walking? Okay. Are you okay with this setup? Okay. Let me think of the best way to go forward from here. I know we can set up a proportion. Well, I want to say that would work, but I'm not 100% sure. That would be 16/9. Is the answer E? The answer is not E, so no, not that. I feel like I'm missing a piece of information in here. Let me look at my work real fast. Okay. Yeah, I was thinking that. So what you're thinking about the multiplying by 4, I get why you're thinking that, but the reason why I was hesitating is this is a length, but this is a rate, and this is a rate. So I didn't feel comfortable making a proportion with those. So what we could do is we could say this length is X, and this length is Y, and not that y'all need to like go around the room or anything, but I've got several posters up from this geometry topic that you guys did when you had these small triangles within a big triangle. In geometry, you would have set up a proportion. So like 2 is to 8 as X is to not Y. Right. X plus Y. Those sides are always proportional, and then you could cross multiply and combine like terms. So it looks like Y is equal to 3 times X. And now we could take the derivative of this and see what that gives us. Y with respect to t, 3x with respect to t. Yep. And which one of these two are we trying to solve for? Okay. Do we know x prime? 4/9. And then when you plug that in, it gets you 4/3, which was the correct answer. So that one, not really a geometry formula, but just more of a geometry concept. Setting up this picture and using the picture to set up a proportion. But don't mix and match. Don't mix and match the links with the rates. Just do links. Okay, how about the first ones? Number 1 or number 2? Edward, did you have one?
No, I was going to ask you about this one.
Oh, okay. So again, I know y'all get sick of me saying this, but this is where, I try to help y'all out as much as possible. Do all of you remember seeing this? Probably. But this was a real AP question. Do you have to do proportions from similar triangles like this in the future? I mean, probably once or twice more this year, but that's where I said you really, really, really have to know the basics of calculus, because sometimes you're not going to remember the basic thing that they need you to do. And so you've got to make sure that you can knock out as many questions as possible. So, all right, can I take one more today? Okay, so what I'd like you to do is I want you to continue on this assignment 36. You guys still have some class time here. I'm just trying to make sure you know. You still got about 12 minutes. But where I need you to be by Thursday is this number 36 has 17 questions on it. I'm asking you to make sure that, or stick with it long enough that you feel good about 10 of the questions. So if you try the first 5, but you don't feel good about them, you're not getting the right answer to them, those don't count towards your 10. I'm talking about 10 questions that you work, that you're getting the right answer to, and you feel comfortable with. That will, of course, allow you to try some questions that you get stuck on, and you'll know some that I can help you on next time. At the same time, helping you continue to get practice. I will also add to the website the solutions from past years, which is pretty much every question. So if you can't find 10 to figure out on your own, you can lean on my class videos to help you get to 10. So you should have a little more than half of it done next class. Everybody okay with that? All right, I'll let you work a few more minutes here. Again, y'all have 10 minutes till you're dismissed. I'll switch to the daily puzzle here in a few minutes, but
I think my main problem is finding the derivative of cone.
with R's and H's,
Yeah.
yeah, you have to do product rule if you have R's and H's. But the good thing is, like, if that's the one thing, just you can do it 5 times. It's gonna be the same thing every 5 times, so it should get easier.
And I forgot what it was, but the Google Classroom assignment, it closed when the due date ended, but I just was going to mark it as done.
Okay, does it not let you mark it as done after that?
No.
Okay.
So it appears as missing. I just didn't turn it online, basically.
Yeah, I understand. Do you happen to remember what number it was?
You pull out my Chromebook.
No, it's fine. You don't have to do that. I'll check. I'm in the wrong class. Sorry, I'm looking, but I can't find one that says that.
I'll pull something.
I'm checking everything. maybe I already fixed it. Yeah, I'm sorry, I don't see it. Okay, so you guys got about 6 minutes, so make sure you know where you need to be by Thursday. Find a decent stopping place. Borrowed one of my calculators, please start bringing it back. And I want to say you already did this puzzle. Yes? Alright, then today's is 8 small puzzles. I would say number 7 has been the most unknown, and then followed by 8. For my classes that already did this one.
Get it. Blackjack. Backdoor, next one.
That's number 28.
What is this?
I don't know. I'm looking at 28. It doesn't say. There's a button that says close submissions after due date. I can try to edit it and see if it'll update it.
Oh, okay, there it is.
Okay, it must have just glitched.
Yeah,
Okay, so what's number 1? Forget it. Okay, number 2.
Jack.
Yeah, I think it's supposed to be Jack in the Box, but blackjack also kind of works. Number 3.
Somewhere over the rainbow.
Yep. Number 4. Back door. Number 5.
Read between the lines.
Yep. Number 6. Blood is thicker than water. Okay, I'm gonna guess nobody figured out 7. It might be a little bit older saying. What about number 8? You guys are also maybe too young for number 8. Canceled check. The word's canceled and it's in the shape of a check. You know, like a check, you write a check for money. That's why I said you probably do. Number 7 though, no guesses? What's the word? What shape is it in? Beeline, yeah. No one's figured that one out yet. That one's kind of weird.
What shape is it in? Beeline?
Yeah, 7 is beeline. That's what they were hoping.
No, that's no. The others make sense, but that one is,
Beeline?
yeah, that one doesn't make sense.
Have you ever heard that before, beeline?
No, I know what it is, but the way they
Oh.
put like the puzzle.